So this is another IP experience with Guy, which I'm very envious of because, to be honest, when I saw this product, I was just salivating. It's an incredible development for MEMS microphones, and as someone in the musical sphere, anything microphone related, I'm pretty hot on. And this is the development kit. So enjoy the interview first, and then in the outro, I'll take this out of the box. We won't do a demo, but one day we will do a separate video on that. So enjoy this interview with Soundskrit.
So today we are talking to Sahil from Soundskrit, which is a very nice technological play on words. Very good. I noticed that. Now, tell me how you make hearing and sounding the impossible, which is what you play on your website. Tell me all about your MEMS microphones, which is what we're going to talk about.
Yeah, absolutely. And first off, thanks for having me. So,
our pleasure.
Soundskrit, we're developing a new type of MEMS microphone. The unique aspect of it is that it's directional. So if you look out in the market today, all microphones are omnidirectional. So if I want to pick up somebody's voice who's talking a few meters away from it, I'm also picking up all sort of the surrounding noise that's a few meters around it. And so because of that, you have all these experiences where you're on a phone call or a conference call or something like that. You hear all this background noise coming in. It's hard to hear what the person is saying. You're constantly asking them to repeat themselves. You don't feel as confident when you yourself are trying to talk and present yourself. Our microphone, it's inherently directional, so it's a new piece of silicon, a new piece of hardware, and you point it at a specific direction, and it only picks up the sound from that direction. So even as you have your colleagues or office mates kind of around you, or noise coming from outside or the road or anything like that, it's still able to kind of just isolate your voice while not bringing in any of that background noise. So really trying to improve voice calling, conference calling, things like that. You could also think about applications that involve speech recognition and things of that sort, where you often have to, ask Alexa 5 times and repeat yourself to do something. So it's really just about kind of isolating user's voice and then clearing that up from the background.
Okay, so let's just make this clear now. At the moment, particularly post-pandemic, with using this kind of environment, getting rid of noise has been very effective, which you can do in all sorts of different ways, software, or using, I take it you can use multiple types of microphones which are listening in different directions. So where do you see your clear differentiation? I understand that you call it directional, but where do you see your clear competition in terms of how that problem is solved now?
Yeah, so right now the way that people do it is that they use microphone arrays. So if I take something like my laptop in front of me, it has 4 microphones in it. So it has that omnidirectional microphone times 4. And then they use software to try and effectively make a beam that listens to me and blocks out surrounding noise and echo and reverb and things like that. But they're using something that's like not directional, and they're using a lot of them with software to try and make something that's directional, right? Because we bring kind of the directionality into the hardware itself, we actually find that we get much better performance. And along with that, we can use less components, right? We can go from 4 microphones to say 2. So then you're also thinking about saving on power, computation, just less components in general that you got to integrate into the device. And while they do this right now, I'd say that the performance is still kind of subpar. So right now I'm talking through my headset. I'm going to see if I can switch to my microphone array on my laptop here. Can you hear me now?
Yes, it's a lot worse.
My audio just changed. So now I went from the microphone right in front of my voice to the one on the laptop. I'm in my office, totally quiet, no background noise. It's just the echo and reverb around me, right?
Yeah.
And now as I start to move a little bit farther back, it probably got a little bit worse. You hear a little bit more reverb. My voice doesn't come out as clear, right?
Yeah.
Let me just switch to my microphone here. Can you hear me now from here?
Very clearly.
It's a lot more clear, right? So how do I get this kind of experience like off my headset, but into a device like my laptop, or in a device where kind of the microphone is far away from my voice? That's what we're trying to bring.
So that's the problem you're trying to solve. You're trying to solve the fact you don't need these, you don't need this. You're just going to be able to talk to it naturally. Right, I understand. Okay, fine. So,
Yeah.
so you know, you've talked about using software and you've talked about using multiple devices. Is there a cost saving in this solution too? Bearing in mind you'll just be going down to the one device.
I mean, potentially, but honestly, we don't see this as a cost saving kind of technology. I mean, it's true that you can reduce the number of devices, but we're all about performance.
Right.
Fundamentally, when you use microphone arrays and you use a lot of microphones to try and get directionality, physics just says that there's certain limitations that comes with, and that hurts the audio quality, right? So for us, it's less about trying to reduce the cost and more about bringing the performance, right? And if we do end up reducing the cost as a side effect, that's great. But we're a startup here. We're not competing on cost. We're really competing on that ability to isolate a user's voice and have very, very clear communication.
Right, right. So if today somebody, obviously this environment isn't going away, and the Alexa device and the talking to devices in cars, in all sorts of devices, that's just going to continue to grow and become. We're going to get more interactive, more AI. So where do you see where do you see? I mean, you can talk about these consumer devices, but in the future, this sort of typical environment, this is a clear application environment. Do you see any other kind of applications where you see this problem being solved, as well as in this sort of environment with Teams and where headphones would be used? Do you see there are other advantages in other applications?
Yeah, sure, absolutely. So obviously this is one. We've gotten a lot of interest in like AR and VR type applications as well. So for example, we're working on a few different types of AR glasses that beyond just kind of voice pickup are looking at doing things like real-time translation. So one of
Oh,
the
right.
features that we see people looking at is
Yeah.
you're talking to somebody, you want to pick up their voice in front of you, block out the surrounding sound, and then actually translate what they're saying and transcribe that on the glasses itself. So we have a reference design we're working on with one of our partners on that. Hearing assistance is another big one that we see, both for AR glasses and more like TWS and earbud form factors. So we see a lot of people now starting to look at, hey, how do I pick up the voice or the sound of whatever I'm looking at? So just in front of me, not behind me, and then play that through the speakers, whether it's in my earbuds or my AR glasses, and actually kind of just amplify some of the sound in front of me, right? So again, you're going into more like hearing assistive, augmented type applications. So we
Yeah.
have a few folks looking at doing stuff like that. Um, you mentioned automotive too, I think at one point. Outside of just
I did.
consumer devices. Um, I mean, this is more on voice calling, but talking to somebody in a car must be like one of the most frustrating things ever, right? Like it is
Yeah,
so hard to
totally.
hear people.
It doesn't
Um,
work. Let's be
Yeah,
honest.
absolutely. And like,
I'm still yet to have a car where voice recognition works. I mean,
oh,
yeah, it's a total disaster as far as I'm concerned. So,
yeah, that's the
oh,
worst, right? And and
yeah,
and and you want to do things like, hey, take me to this location and put it into your nav. It never gets your address correct, right? But the automotive car, it's so noisy, right?
yeah.
Um, take that a step farther. We've seen some automotive companies talk about doing things like in-cabin communication. So I have a seven-seater, and you have the kids all the way in the back and somebody in the driver's seat. Instead of the driver having to look back to talk to their kids, if you could pick up what the kids are saying in the back, play it through the front speakers, and vice
Oh,
versa, then you can actually help the communication in the car itself. Um, People have talked about kind of localized experiences too, right? So I can not only isolate voice, I can tell you where that voice is coming from. So is it coming from the driver or is it coming from the kid in the back seat? Maybe there's certain features that you don't want the kid in the back seat to be able to play with, like your navigation or certain safety functions. Maybe only the driver should have certain ability to control certain things. And so the ability to kind of use directionality kind of helps you make more informed decisions and kind of smarter systems as well.
right, right. So, I mean, if we're going to take a potted answer to this whole very clear directional approach to what you're doing is actually the secret. So, now this is obviously this is unique to you. Are you the only people that have this approach?
Um, Other people have tried to make directional MEMS microphones in the past, but they've used very old traditional technology. So what they kind of did is they took the old microphone and they kind of repackaged it to try and get directionality. And when you do that, we see that it takes some performance hits. I'd say we're one of the first that we've seen that have really redesigned like the MEMS component, the actual silicon for directionality. And so I'd say our
Yep.
approach is very unique, although we have seen other people try and make directional microphones in the past.
Right. And is the secret sauce in that the software?
The secret sauce is really in the hardware design. The
It is in
silicon, how
hardware.
he does, yeah, how he designed the silicon, how he make it move in response to the air, get really good sensitivity. We
Yep.
also do have a software piece to this as well. We've developed kind of our own AI and noise reduction algorithms and a variety of different features that really leverage what our microphones are sensing to kind of get the next level or bring out that feature to the user. But the core technology really starts with that new piece of hardware, that new silicon.
Right, right. So obviously the key thing here is that, I mean, we can talk about it, and you really articulated extremely well new application areas. I mean, you've talked about things that I wasn't expecting you to talk about. So how would an engineer today get hold of? Is there an application board that they can get hold of?
Yeah, we have demo kits, a variety of different demo kits. For example, there's one demo kit we call the Horizon. It's a little board that just mounts to the top of your laptop. It plugs in through USB. It's meant to get up and running within a minute or two, and it comes with a little graphical interface where you can switch between different types of microphone arrays and software features that we have. So we have a variety of demo kits like that. For folks who want to really get their hands dirty and are a bit more familiar with microphones, we also sample, you can just get some surface mount samples, build them up on your own boards. And, our team here in Montreal is great too in terms of giving support. So if anyone wants to try this stuff, we're happy to get on a phone and kind of help you work through your product and your solution as well.
Right. Fantastic. Well, this has been one of the shortest ISP experiences I've actually done, but I think we've actually covered off everything that we need to talk about. You've explained the application, you've explained how you've solved it using hardware, you've explained that you can go in all sorts of variety of applications. You have a board available so that people can play with it. You have a fantastic support system behind it. So thank you very much for coming on our IP experience. Is there anything else that you'd like to add? Apart from I have a very cool hat, which goes with a very cool logo, which goes with a very cool T-shirt, which is if you go onto ipexchange.tech and apply for your board, so you can evaluate your rather marvelous MEMS sensor, you can apply for one of our T-shirts. Is there anything else that you'd like to add?
Oh, awesome. Well, I might have to get one of those hats too then.
We can
No,
send you one. We can do that.
no, thank you so much for having me. We're really excited about the technology that we have here. We think it's really something that's quite unique, and anybody who wants to get a hold of us, just reach out through our website as well, and we'd be happy to chat some more.
No.
Or through IPX.
Where else might they go? Where else might they go?
Yes,
if IPexchange.tech
IPX.
is where they might go in order to evaluate your rather marvelous technology.
Yes. I apologize. Absolutely.
Right. You enjoy the rest of your day. Thank you very much for coming on our IP experience, and we look forward to hearing about developments in the future.
Awesome. Thank you so much.
So that was Guy and Sahil from Soundskrit. Very interesting, right? I mean, thinking about having 4 omnidirectional microphones just to do the job of one of Soundskrit's is crazy, especially considering Soundskrit's solution is so directional. You don't need a bunch of audio post-processing to figure out what you're trying to listen to within the noise. But as promised, this is the Horizon demo kit that Sahil was talking about. So this came in a lovely box with some sweets I've just finished eating. Nice, very, very nicely presented. We'll do a proper video demonstration on this at a later date because I am very keen to see how it performs, and maybe we'll even do some musical covers. I don't know. I'll see how I feel. But this is essentially it. So you can see there is a sound bar. There's a little board on the back, which is where it plugs via USB-C into your laptop. So you can actually just use this on calls to really test it. There's these clips on the side, which just screw and then put your laptop in, screw them closed. And as you can see, there's a few of Soundskrit's microphones just dotted along that. in an array. So check out the full technical write-up on the board page, because that's got a lot more information about the audio specifications of these microphones and what patterns can be achieved using that array of microphones. So I think there's everything you'd expect. You can make it omnidirectional. Obviously, you can have the highly directional. You can have hypercardioid, cardioid, I think some other ones. But yes, for anyone who likes microphones and anyone who wants to put a microphone into a product, you've got to check this out. And if you have a project that warrants getting a kit like this to evaluate them, you're going to have so much fun, because I know I am. So evaluate today.